Okay, so in 9.4 we talked about the tangent ratio, and now we're going to talk about the sine and cosine ratio. The tangent ratio is the ratio of the legs of the right triangle. It doesn't involve the hypotenuse at all. Sine and cosine both involve the hypotenuse. It's one of the legs and the hypotenuse for both. But they're different legs, so it just depends on which one you're using. Okay, so in this triangle, I'm using the same triangle we used for tangent. We'll first look for sine of angle A. In sine, the sine function of an angle is the ratio of the opposite side over the hypotenuse side. So let's go over here and look. We're at angle A. You have the hypotenuse, the opposite side, and the adjacent side. So let's say you're standing in this room. There's a room shaped like a triangle. You're standing here. The opposite side would be across the room. The adjacent side would be the side that you're right next to that is not the hypotenuse. So if sine of angle A is opposite over hypotenuse, then the ratio would be 3/5. Cosine of angle A, COS, is the adjacent side over the hypotenuse. And the adjacent side is 4, and the hypotenuse is always the hypotenuse. It's 5. Okay, now let's find sine and cosine of angle C. So sine of angle C is equal to, still opposite over hypotenuse, but since we're talking about angle C, you're standing on this side of the room. And these two things switch, just like it did with tangent. Those two things switch when you're referring to a different angle. So opposite for angle C is not 3, it's 4. And hypotenuse is always the hypotenuse, it's 5. Cosine of angle C is adjacent over hypotenuse, which is, for angle C, 3/5. Do you notice a pattern, anything that's the same? Any of the answers that are the same? Oh.
The sine of C is equal to the cosine of A.
Okay, that's correct. And then the sine of A is equal to the cosine of C. Remember that, because we'll look at something in a minute where that will matter. So it's like they're opposites when you go to opposite angles. The numerator changes because your opposite, your adjacent becomes your opposite becomes your adjacent when you switch to the other angle. All right. What's next here? Okay, so first we'll find x. If we're looking for x, then y does not matter. It wouldn't help us anyway. We don't have a value here. So we want to look at everything but y. And it may be helpful till you get used to this. This is the only angle that we have, other than the right angle. This is the opposite side to that angle. This is the adjacent side. And this is the hypotenuse. So we have to figure out, they don't tell us which trig function to use. We have to figure out which trig function to use. When you did tangent, you only had tangent to do. Now you have 3 choices. but there's only one that will work for now. So if I'm looking for x, and I have the angle across from it, and I have the hypotenuse length, what trig function would I use to find x, to set up my equation? Sine. Because cosine has nothing to do with the opposite side. Cosine is adjacent over hypotenuse. But sine is opposite over hypotenuse. I couldn't use tangent. Tangent does involve the opposite side, but it also involves the adjacent side, and I would have two variables in my equation. So sine of the angle. Angle always follows the function. Do not ever put the side measure of the triangle after the trig function. Is equal to opposite over hypotenuse. What did I just do? That is not a degree. That is not an angle. Okay, so now you know this part. You know how to solve these from tangent. And this is the way I do this is the way I want you to do it. Multiply both sides by 53, and x is equal to 53 sine of 35. Because what we're doing is this. That 53 and 35 is messing me up here. So you're multiplying both sides. This cancels, and x is equal to 53 sine 35. Don't put the 53 over here by the 35. If you're multiplying a trig function by a number, you need to put it in the front. So this part in blue you do not have to show, but I do want to see this original, the way you set up the equation, and I want it to see it solved for x. How you go about solving it for x, that's up to you, but I want to see this original problem solved for x, and then give the answer. $30.4. Did anybody else get that? Now we'll find y. What trig function do I use to find y? Cosine. So cos. You could. What I like, that is a really good point. Let me write this down, and then I'll talk about that. Cosine of 35 is equal to y over 53. So, yes, we know what x is now, 30.4. The reason I would not use this, you can, but if you're going to use a decimal answer to plug in to find another value, you need to take it out 4 places so that you can be more precise with your answer. But by using the original number here, that's not a rounded number, it's just a, it's not a rounded decimal, your answer would be more correct. And we could actually try that to see if it would be the same. So y is equal to 53 cosine of 35. There's also another way to find it, and I'll be thinking about that, see if you can figure out what that would be. 43.4. You need to be seeing if you're getting the same answer as I'm getting with your calculator to make sure you know how to use your calculator. Any ideas on a different way to find x without having y, without involving y? You don't have to know this, but can anybody figure out a different way to find x? Let me move some of this stuff and maybe there a different way to find x? Is there a way to find x using cosine? This is not something, don't let it confuse you with everything you've learned so far, but you kind of need to know that this will work. Do you know the other angle measure? So if you know the other angle measure, could you use cosine? Let me just show you. You don't write this in your notes, just watch. So if this is 35, this would be 55, right? We always know in a right triangle, if we have one other angle other than the right angle, we know the third angle. And so we could say that cosine of 55 is equal to x over 53. So x is equal to 53 cosine of 55. And let me see if I get the same answer I got up here. So when I put this in my calculator, I get the same answer, whoops, that I got there. But you don't have to know that, cats. In case that, does that make sense to anybody in here? Okay, good. All right. Let's see what's next. What we just talked about will help you on this one. Write cosine of 68 degrees in terms of sine. So if I went back here, I should have left that over there so that you could see. If I wanted to write sine in terms of cosine, all I had to do was change my angle measure. And what did I change it by? So all you have to do is say that cosine of 68 degrees is equal to sine of 90 minus 68, which is let's check this in our calculator. What is the cosine of 68 degrees? And then what is sine of 22 degrees? So cosine of 68 is equal to sine of 22. So you subtract your angle from 90, and it gives you the other angle, which changes your opposite and your adjacent, and gives you the same answer. This is just checking our work. This is what your work should look like on a problem like this. We're just checking it. You don't have to do this part on your homework. Just this part up here. I'm just showing you, I'm proving to you that the cosine of 68 is equal to the sine of 22. And how you get that is subtract 68 from 90. It's called a cofunction, which I don't think it's defined in this book yet. You're just supposed to see how that works. All right, next. We're going to find the sine and cosine of 45 degrees without a calculator. Anybody want to guess why we can do this without a calculator? What? Because of what?
It's not decimal
It's a 45, 45, 90. If we're trying to find the cosine of 45 degrees, then that means we have a 45, 45, 90. I'm not going to label both. I'll just label one. So there is a way without a calculator to find it. So the rule for a 45, 45, 90 is x, radical 2, right? Well, let's put any number we want to for the leg. Let's choose 1. It's the easiest number, right? We can't use 0 because the length of a leg cannot be 0. So let's choose 1. That's the easiest number to work with. That means this one is 1, and what is the length of the hypotenuse? 1 times the square root of 2, which is the square root of 2. So sine of 45 degrees is equal to 1 over the square root of 2, because this is opposite and this is hypotenuse. This is adjacent. And if we rationalize that, the sine of 45 degrees is the square root of 2 over 2. Now, maybe your calculator will give you that as an answer, only if it's a Casio or a certain type of Texas instrument. But most of your calculators will only give you a decimal. So I'm going to compare this to what my calculator says the cosine of 45 degrees is. So the square root of 2 divided by 2 is approximately 0.7071. Now, put in the cosine of 45 degrees. Put in the sine of 45 degrees. Same. The cosine of 45 degrees is adjacent side over the hypotenuse. And because I already did everything over here, I know that 1 divided by the square root of 2 is the square root of 2 over 2, which is approximately 0.7071. You only have to give me this as an answer, but we're just checking. Let's now do the cosine of 45 degrees. Same thing, 0.7071. So let's say I chose, instead of 1, I chose 7. Well, 7 and then 7 radical 2, if I put 7 over 7 times the square root of 2, my 7s would reduce to 1 over the square root of 2. So no matter what number I put here, it will still reduce to 1 over the square root of 2, correct? And it makes sense that my two answers will be the same. Why? A couple of reasons. One, because the 45, 45, 90, we know the legs have the same length. So opposite and adjacent, they have the same length side. It's an isosceles triangle. Also, by this reason, what we just learned on the previous page, all of that holds true, right? Because it's right in the middle. Right in the middle. Okay, next. It's a lot to learn in one section. But half of it we already know. We already know a 45, 45, 90, the side lengths, how they compare to each other. What about this one? Sine and cosine of 30 without a calculator. Well, what is 30? If I have a right triangle with a 30-degree angle, what kind of triangle do I have? So if I draw and label a triangle, a right triangle with a 30-degree angle, remember it was x, 2x, and x times the square root of 3. So let's let x be 1, because that's the easiest number to use. What would the hypotenuse length be? 2. What would the long leg be? Square root of 3. You're in algebra 2. This is helping you out right now. So the sine of 30 degrees is equal to opposite over hypotenuse, which is 1 over 2, 1/2. So if you're having a hard time memorizing those things in algebra 2, then think of your 30, 60, 90 triangle. Sine of 30 is 1 over 2. Cosine of 30 is not 1 over 2. It's the square root of 3 over 2. Put the sine of 30 in your calculator. It was funny earlier today. I said, okay, put the sine of 30 in your calculator. What'd you get? 0.5. Like that's the wrong answer. What's 0.5? 1/2, right? So the calculator says 0.5. I say 1/2. It's the same thing. That's correct. Now let's put in cosine of 30. It's 0.866025404. Well, let's see if that matches. The square root of 3. By the way, when you do put that in your calculator, you have to, some of you, depending on your calculator, have to close the parentheses after the square root part before you divide by 2, and you should get 0.866025404. Okay, well now let's say, just for you algebra 2 people, since we only had to do 30 degrees here, what if we wanted to do the 60-degree angle? We just use the same triangle. What is the sine of 60? It's the cosine of 30, right? What is the cosine of 60? It's the sine of 30. 1/2.
That helps tremendously.
Okay. If you want any help on the unit circle, she probably does the same thing, or maybe some of it's a little bit different, but I can help out finding patterns in there. And at the hand trick, I know usually after they've had her with the hand trick for algebra 2, then they come in here for pre-cal, they either forget or they're like, I never did learn that because I didn't try it, because it's an option. It's optional to use hand trick. Hand trick is very useful. 30 degrees, 45 degrees, 60 degrees. Have y'all talked about that?
Yeah.
Okay. So if you're having trouble with that, get with me. I will show you how to do it. I use it. It's very, very, very helpful. And it will help you with all of your angles all the way around the circle, just by knowing that one quadrant. Okay, let's see what's next. I think this is the last problem. It's application. You're skiing down a hill with an altitude of 800 feet. The angle of depression is 15 degrees. Find the distance x you ski down the hill to the nearest foot. So anytime you hear something like that, especially angle of elevation or depression, you want a right triangle. Most of the time in application problems in geometry, you're working with right triangles. So just draw a right triangle. I'm going to draw, let's see. Something like that. It's probably not that steep. Oops. That's the ground. How do you measure altitude? Would you measure it this way? Would you measure it this way? Would you measure it this way?
Yes.
Yes. Altitude, perpendicular distance to the ground. Well, assuming the ground is flat. You know what I mean? Like if it wouldn't be perpendicular distance this way, but, you know. Okay. Angle of depression. Remember, angle of depression would be if you're on top of the mountain, your horizontal line, and you're looking down. That would be right here. And depending on what we're looking for, I don't know, will I use this angle up here, or will I use this angle down here? It says find the distance x you ski down the hill. Do you measure this to ski down the hill? you would measure this, right? So X goes here. Here's my triangle that I'm using. And so I'm going to use parallel lines cut by transversal to see that my angle of elevation is the same as my angle of depression. They are the same. You could always make your parallelogram though. Whoops, right here. And you could use that. It would still work. I just like to use the angle of elevation if I can, which is the same. So, what trig function? Sine, cosine, or tangent? So we have, here's our angle. We have the opposite side, and then this is the hypotenuse. We don't have it, but we need it, so it has to be in the equation. And that would be sine. Not sin. We don't sin here. When the x is in the denominator, switch it out. To the nearest foot means what place? The ones place? To the nearest foot? Okay. All right, I bet you want to know, how are you going to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent? You guys still writing that down? Well, do you know how to spell SOHCAHTOA?
Of course not.
Okay. Can you remember some old hippie called another hippie tripping on apples?
That's how she told Black.
Tripping on apples.
Apples, you say.
Apples, I say.
Apples, you say. That's not what you told me.
And what is this called when you have letters representing words? Acronym. So sine of the angle, I don't care if you put theta or x or whatever here, is equal to opposite over hypotenuse. Cosine of the angle is equal to adjacent over hypotenuse. Tangent of the angle is equal to opposite over adjacent. So when you go, okay, what is sine? Some old hippie. What is cosine? Call another hippie. What is tangent? Tripping on apples. Whatever helps you to remember it. Okay? So maybe that will help you. You will see this, till the end of the year. This year you'll see it at least in a couple of chapters next year. And in geometry for 3 whole chapters we're using sine, cosine, tangent. And by that time you're really expected to know this stuff walking in the door, knowing the basic stuff about trig. Okay? All right. And here's your assignment. So what we're doing today is I want you to spend the rest of the class time working on this assignment, asking questions as needed, because I didn't work that many problems where you're looking for the length of the leg. I worked 2 problems. So you may need a little bit of help. But what I'll do is, instead of working 9.6 tomorrow, I will let you finish by the bell, have it turned in, period. If you're not finished, it gets turned in. So don't put everything off until tomorrow, because you may not have time to do all of it in one period. So do some of it now, and you'll have to be finished by the end of class.